Hello developers. In today's session we are going to explore ZIG programming language by making a clone of word count application. So ZIG is basically a general purpose programming language, and it's a tool chain for maintaining robust, optimal and usable software. So I read a lot about ZIG, and I thought of sharing my thoughts, with the community by cloning the word count application, which is available with every Linux installation. So as the rest has already claimed, the internet, it's a better C++. Um, you know, so ZIG is you know is is a better C. That's what the people is saying on most of the internet online forums. And I thought, to whet my appetite, it's better if we can explore the language by making a clone of the word count utility. Okay, so what we can do is we can just make it clone of word count application, which is literally available with every Linux installation. So the way it works is, as you can see, I can invoke the application by typing wc word count and pass the file, and as you can see, it reads through all the characters, and then after gulping all the characters, it will display the number of new lines it has, in this case 20, and the number of words it has is 425, and the total bytes it has, which is 2574, and this is the file. So let me open the file and show you what it got. Then the way it interprets. So I am using the hex editor, so I can just open it. This is my file. As you can see, it got some text. Okay, so what I can show you is how it is going through the number of characters and finding out the number of words and the new lines. Okay, white space render. Okay, all. So let me just turn on this. As you can see, now the displays is showing it's a new line here. Okay, and the words are the words are separated by a dot. So the way it treats words is by the space. Okay, and it treats new line by the new line the user has entered. That's a \n on Linux, and if you are using if you are on Windows, it is \r\n. Okay, so it is what it does is it reads through the characters, and if it finds out a space, then it counts word 1, word 2. Here in this case, it reads the word, but it encountered a new line. So it will check, oh, did I read the word? Yes, then it will count that as a word, and also it will increment the lines, new lines it encountered, and finally it displays the output. So just in case, if you don't provide the argument of the file name, so by default it opens stdin to read from the user input. As you can see, the cursor is waiting for me to input. So let me just type in a quick brown fox jumps over a lazy dog. Okay, I entered, and to hint the shell I'm done, I can press Ctrl B. Okay, now it read through this input from stdin and find out, oh, it got one line and 9 words and 40 bytes. Okay, so just to know what we're gonna do, we can just type in wc help -help, and it displays all the options available. So probably in this session, most likely what we're gonna do is we are going to implement this one, number of lines, number of words, and number of bytes. So if you don't provide any switches, by default it is assumed to be on the bytes and the words, and the new line as it displays here. Okay, the number of lines, number of words, number of bytes. Okay, then it displays it. Okay, so in the previous session I did a video about the Mees, which is a front-end development tool to deal with multiple tooling while doing the projects. So let me just create one folder for this called my wc my wordcount. I know it's not very creative name, so try to type zig. There is no zig here. It is prompting me to install zig, but I'm going to use Mees. So Mees use zig 0.151, which is the latest one. Mees use ZLS 0.150, and I can simply Mees ls. Now zig, both zig and zig language server are available, so I can just type in here hx. Let's go over the contents of this folder. ls, nothing is there, just the Mees toml file. So let's bootstrap our zig application. So zig init, so you can just to explore you can type zig -- help, and it provides all the available options. So I'm going to use init to initialize a zig package in the current directory in this folder. Okay, so zig init, as you can see, it has created this much these files: build.zig, zigzone, this is the package manager, and this for the library, and this for the driver application. So mostly we'll be focusing on main.zig. So let's build the zig. So I can issue and one more command here, zig build run. As you can see, it is compiling and run, and it outputs all your code bases belongs to us, and it is prompting me to write the test. I can also type in zig build test. Okay, so what we're gonna do is we're gonna open it. Okay, as you can see, this is the file I was talking about. So let's get rid of this. Okay, we don't want anything, so delete, and then we want a main snippet. Okay, and we also want stud, const stud equal to import stud. So stud is a standard language, it's not import, it's @ import. Okay, so I can type in, I'll come here and I'll type print hello zig. Okay, and save and quit, and say zig build run. Now it displays hello zig here. Okay, all right. So what we can do is we can start writing the application. Okay, so let's create what we're gonna do. We are going to go to our main.zig, and let's create for supporting structure. So I call it as const result, which I'm going to display result as a struct. Okay, and this will have show bytes, which is of type boolean as true. Okay, and then or we'll just turn it out. Okay, so let's first have it false. Sorry, false, and say total bytes of usize. Think I mean this maps to the operating system max word size, and let's initialize it to 0, and show words, which is again a boolean switch. Okay, and by default it will be false, and total words, which is again a usize, equal to 0, and show lines. By default I'll treat this as to be false, and total lines, again u size equal to 0. Okay. Now, what we are gonna do is, we don't want this, I just want to make sure it was working. So, I can just remove this file. Okay. And now, let's declare few variables here. Okay. So, as I shown to you guys, like we have to accept the command line arguments. Okay. So, in order to display those arguments, what we can do is we can rely on the var args. So, stud process and arguments. As you can see, args is a functions which it holds, as the text says, holds the command line arguments with the program name as the first entry. Okay. So, we can read it. These functions return an arg iterator. So, I can just pass in how many iterators, the arguments I want. For example, just display the arguments, print displaying arguments. Again, you give the new line, and here I'll say for args. Okay. Then arg. So, I am looping over the arguments. Okay. Which is an iterator, and each argument will be placed in this variable. So, I can simply display print arg equal to s and new line and arg. Okay. So, let's save and quit. Say build it, zig build. Oh, it says local variables never muted. Okay. Arg iterator is not indexable, so we are running into issues. That's fine. Open it up. So, it is while args dot next. So, next returns an optional argument instead of for. So, it is not iterable, it is saying arg, and I can just remove this. Okay. And format, and I can build it, zig build, it build. So, zig build, I can pass the parameters. To pass the parameter, just include the 2 dashes. Okay. I can say example dot text, or I can always say minus c minus w minus l and example dot text. Okay. Well, zig build, I have to pass run, sorry. So, now it is displaying the arguments as we have written. So, as you can see, the first argument is always the application name what we have passed. Okay. That is my wc, and the second argument is read as minus c minus w minus l, and the last argument is the Linux has expanded this automatically for us. So, this is the current working directory for the user which has expanded to /home/Hamid, that is my user, and the example dot text. Okay. So, what we can do is, based on what we have learned so far, let us start parsing this. Okay. So, let us get rid of this, and we know the first one is always we do not need this. Okay. So, skip first argument. So, to skip, I can simply say underscore args dot next. So, that discards the application, the first argument, that is nothing but our utility name, that is my wc. Okay. And then what we can do is, let us initialize few variables. Okay. Um, so bar show bytes equal to false. Okay, this we have initialized, and var show words equal to false, var show lines equal to false. Sorry, this is C language, C like language, and bar file path. The file path we have, it's a optional const u8, so it takes an optional slice to constant u8. Okay, so maybe we can have one more variable there. Okay, to hold the file name optional const u8, and let's define it as null, because it can be null. Then in that case what we do is I will open the stdin file by default. Okay, okay, so then what we're gonna do, let's go while args dot next. Okay, that as we have previously done, arg, this is an optional arg. Now let's compare. So to compare, we can say stud mem equal, that's available, which is of type u8, and we'll compare it minus c, that's the switch. Okay, if it is equal to this, or stud mem equal, u8, so we have to compare with our argument, of course, arg. Okay, argument with minus bytes. You remember these switches, so it is either minus c or minus bytes, correct? If you are confused, let me just grab it for you. Minus help. You see, minus bytes, these are the switches. This is a short switch and the long switch. The next switch is this one. Okay, let me copy that. Again, open it back. So if we come across this, okay, what we're gonna do is we're gonna say show bytes have been turned on to true. Okay, else if it could be the other one. Okay, what is the other one? The other one was this one, minus l, stud mem equal u8 argument with minus l, compare with minus l, or argument minus l, or stud mem equal u8 argument with minus lines. Then in this case we said show lines has been turned on. Okay, and else if stud mem equal u8 with an argument. You guys remember the other switch? Let me go back. We captured these lines, and now comes the words. Let me capture words. Okay, and here okay, so let's compare with minus w, or stud mem equal u8 argument with minus words. Okay, and then what we have, show words must be true. Okay, otherwise let's get rid of this. Otherwise we assume the last parameter is a file name. Okay, so that is the and let's store that in here in this variable. So file path equal to argument. Okay, now we captured all. Let's format the code. Okay, and we captured all the arguments, and not let's check. Okay, if not show bytes and not show words. So this is the case where user had just invoked the word count utility and by passing the file name. So in this case we want to make sure like we turn on show bytes, show words and show lines. If it is not turned, if it is not turned, those switches are not passed, so by default it will be false. Then what we gonna do? We gonna just turn them on. Show bytes equal to true. I'm sorry. Show words equal to true. Show lines equal to true. And now we turn on. That's the default behavior. Okay. So now next what? So as I told you, the passing file name is a optional again. So in that case, by default, when you invoke a application on Unix or Linux like system or even on Windows, it's going to result into a process. Okay, so by default it is going to open 3 files for you. That is stdin, that's a file hand whose FD will be 0, stud out whose FD will be 1, and stud err and whose FD will be 2. Okay, so remember this. So let's so now we need a buffer to read, right? So let's declare a buffer of 1 KB, so that's 1024 of U8s, yeah, and let's call it as undefined. So this is very good, this undefined, because in C language when you declare an array like this, so by default it will get gibberish. Okay, and if you try to use that one, it may point to some random memory and may result into process crash. Okay, but ZIG is helping those C programmers, because this is once you define as an undefined one and trying to use it, it's a error, and the compiler will flag it. Okay, so let's call this we need a file. File is of type stud fs and file. Okay, so now we have to make a switch. As I told you, the file path is optional. Okay, if file path is provided, file, okay, then we will try to open it. Try stud fs current working directory. Okay, open the file, whatever the file has been passed, open it, and open it what I did. Okay, by passing the flags. The flags are it's read only operation, so I can just pass a an empty configuration. Or so as you can see, this is a if else expression. If this particular condition is met, then this particular file will be opened and returned. Since we are returning this, and I have written here, I'm saying main is fallable. So when say failable, if this particular folder or file is not there, that's going to result into an error. Okay. So that being said, I will say else. So what is the other condition? If file path is empty, we have to open stdin. Remember this one we have to open for user input. So we'll say return stud fs file stdin, you see these are the files I was talking about. So these are by default available to every process, okay, which is of type file. So we return this, and then of course I need to give like this. Let's format it. So we got the file now. After receiving the file, well, I can remove this. I don't need this because I'm writing an expression. So I just can remove it. This is not needed. Okay, and we formatted that. And that being said, this is file start upon. Oh, I messed this up. We don't need this one, these lines. Let's remove it. Okay, so this is some hanging bracket. Let's fix this. As you can see, this is saying unused local variable. This is the beauty of ZIG. Okay, so now we handle the switches. We open the file with a buffer. Okay, then let's instantiate the result. Okay, so to instantiate the result, what we can do is we can create the result we have declared here, okay, and set the switches, and we are going to use that result to display the output. Okay, so var result is of type result. Okay, and just initialize it with an empty one, because we have all the fields which we have default values, so we can initialize like that. Okay, then let's set the switches. Result dot show bytes equal to show bytes. Result dot show words equal to show words. Result dot show lines equal to show lines. Result dot, not this result. Result dot file name equal to file name, whatever we got from up file path. Okay, so we initialize the result. Okay, now let's open the file. Okay, so what we're gonna do is we are going to declare one buffer reader. So the IO has changed in the latest version, so but regardless we need to pass the buffer now. That is much optimal. It would result into lesser system calls, and if you are writing as per Andrew Kelly, the creator of ZIG, we have to make sure like we flush the buffer. Okay. So file, and then file dot reader, because we want to read, and we have to pass the buffer. So pass buffer. Our buffer, we have declared buffer. Okay, and then to read it, what we're going to do is we can say reader and buffer reader dot interface. Okay, so this would return a pointer to the reader, and reader is a an interface. So I can go here, go to the reader. You can see it has a plethora of options. Okay, so stream, discard, and rebase, and whatnot. Okay, So buffer close, buffer close. Okay. So let's see what we got. Reader dot, you see, seek, stream, discard, stream exact. So all the to deal with the character IO or line IO, we got a beautiful interface for this file reader. Okay. So let's begin. We need to capture the words. So I'm going to declare a word, declared as stand array list, okay, of U8, because of course the bytes we are reading. A word is consists of bytes, and let's initialize to empty. So it's empty list, and so defer. This is the beauty of ZIG. I love it. I can declare a variable here, and when I want to get rid of the resources, I can just say defer and say word dot dnit, as you can see, but dnit need an allocator. Okay, so what I fascinated while learning the ZIG was, like, unlike other programming languages which have allocators built in, you know, like C, like you get a default allocator, to alloc, you can say alloc and realloc and calloc, which initializes, and to free up we have to call the free system calls. But ZIG provides a plethora of allocators, being a system language. So you can roll out your own. For example, if you are writing a web assembly, you can create a you can use a different allocator, wasm allocator, but in this particular for my purpose, what I am going to do is I am going to use a default one, say const allocator stud heap and page allocator. That's the default allocator I have. Okay, page allocator. So page allocator is the default allocator. Okay, but if you need a fancy one, what you can do is you can create a var stud heap, and you can say debug allocator. Okay, and pass a variable and invoke a init here. Okay, and then you can say defer. When we are done with the debug allocator, you can say da dot dnit. Okay, and make sure it is resulting into a OK result. So which we can initialize, you can assign to a variable like this. And if there are page leaks, automatically it will be displayed for you. So let's get rid of this. So I need an allocator, but I need an allocator not from the page. So this is a C allocator. I will simply say da dot allocator. Okay, and I will pass the allocator for this. Okay, all right. So I just bootstrap the list, which will be holding a word. Okay, then all right. So let's begin our reading part. So what we can do is we can type while. Now we have a beautiful reader dot take. You see, takes a reader and the number of bytes. So we are interested in reading one byte at a time. So I think there is one more. Let me say, there you go. Take byte. So take bytes is basically relying on the take one. Okay. So take byte, and that byte will be placed here. B. Let's call it as B. B for byte. Okay. So byte is here, which is unused. That's why the language server is showing. So what we're going to do? So we read 1 byte. So we say total bytes plus equal to 1. Okay, very easy peasy. So this is nothing but bump up bytes counter. Okay, then what? Let's check if byte equal to new line. Okay, so now we have to see what we can do if we encounter a new line. So what we can do? Bump up the lines, total lines plus equal to 1. Okay, uh, bump up new line counter. Okay, but as I previously shown you, by the time there could be some characters accumulated in the word, so like we have to check that if word, this one, if word dot items gives us the byte dot length is greater than 0, it means we have accumulated few characters in the word. Okay, so then in that case what's going to happen, we are going to bump up result total words plus equal to 1. Okay, and we are going to clear that accumulator. Word clear retaining capacity, since the buffer it has some allocations, we don't want it to go through the again making the system call for increasing the memory, so we just retain the capacity. That's the beauty of Rust. Okay, then what we do, we say okay, go ahead and continue, so the control will be sent back here again, then it is going to take read another byte. Else what else? Okay, now let's check if stud ASCII white is white space. There you go. There's some it accepts a white space and accepts a character which is nothing but in case of byte. Okay, if it is a white space, then we have to check, did we accumulated any characters in our word accumulator. If word dot items dot length more than 0, same thing, we'll say result dot total words plus equal to 1 and word dot clear retaining capacity okay, we clear it. Otherwise what do you do if it is not a white space? If it is not a white space, then we just accumulate. Okay, try word dot append. So append, you see it takes it's a manage one, so extend the list by one element. You have to pass the allocator. Let's pass the allocator and the byte we read. Okay, byte. Okay, not the local thread, sorry, allocator. If I can type allocator and the byte. Okay, then there could be one condition, because you see this is this can result into an error. Okay, the error can be either it has reached the end of stream or read failed. Okay, but we really don't care about that. Okay, buffer close, but we have to handle it, otherwise we have to try with the with the try. Any failable has to be tried with the try, so I really don't care. So that's a capture and void, do nothing. In other case, you can display some error message, but I'm just leaving it that as an exercise for you guys. Okay, now since now there could be a one edge case, like we have accumulated and now reached the end of string, then let's check for the last word, check for any leftover words. Okay, so we can say if word dot items dot length is more than 0, okay, we have a word. Okay, then result dot words, total words plus equal to 1. Okay, let's bump it up. Then what we're gonna do? We are going to just display. What we're gonna do is print. Okay, and there is a new format specifier which accepts a formatting specifier like for D for number, and S for string, and F for if we have defined a format in that that structure, then that method will be invoked. Okay, so F, and then we display the result. Okay, result, and let's build it. Oh, so you see, I have not I forgot to define the format method, so it resulted in that error. So in that structure I supposed to define a format method. Let's do that. So format, there you go. So format takes a self, with nothing but the same structure, and a writer, so which is after a pointer to a IO writer. Okay, so now what we can do, it's time to display the result. Okay, so you guys remember the utility. So the utility, first it displays the lines. Okay, if so we can say if self dot show lines. Okay, if it is enabled, then what? And say try. Okay, so failable writer dot print. Okay, so let's display bytes. Okay, give a nice space before and after, and here dot self dot total bytes. Oh, sorry, not total bytes, total lines, because I'm displaying the show lines. Okay, if it is there, then we display that one. So do the same treatment for show words. Self dot show words. Okay, then same try writer print, and nice space before after, then pass the tuple self dot total words. Okay, I guess I can copy, right? So I can copy like this, yank it, paste it. Okay, and I just have to change this to show bytes to show bytes, and here I can total bytes. Okay, and what is the last parameter we have? We are supposed to display the file name, right? You guys remember? Let me format it. I think I made a mistake somewhere. Oh, semicolon, I missed semicolons. Okay, so last but not least, if self dot file name, if the file name is provided, then we just display try writer dot print, format specifier, space after and before, S for string, and pass the tuple self dot file name. Okay, semicolon. So we are good. Let's save and quit and ZIG build. So one thing is self dot file name. Oh, it's not a boolean, but rather it's an optional nullable string. Okay, so nullable string. So sorry about that. So I need to capture it as file like this, and I can, instead of self, I can say file. Save and quit. ZIG build. Neat. So now show time. Zig build. Let's run word count to 1 hour example. Okay. So we got 20 lines, 425 words, and 2574 bytes. Okay. Word count. So let's say Zig build run and pass example text. Ooh, ooh, there you go. So now we have 20, 425, same, it's matching. But what is missing? Maybe we missed the new line. Didn't we miss the new line? Probably we missed the new line. Actually, we need a new line, right? Okay, so let's fix that. And here, after displaying the results, I can give a new line. Okay, and run it. Zig build run format. There you go. Now it is, the results are looking very tidy. You see 420, 425 is matching. Okay, now try to display the switches. So what are the switches we supported, right? You remember we supposed to honor the bytes, words or lines. Okay, so you can say zig build run minus lines. Let's display the lines. 20 lines. See, this is even working here. Okay. So that's all I got. So I really had fun. Hope you too have fun, learning Zig and making a clone of that. So until next time, probably in the next Zig session, I am going to take another utility and try to clone and make it fun session, learning Zig. Until that time, keep practicing, have fun, keep developing. Okay, bye for now.